Hello, F Sharp. How are you doing? I am super excited today to talk to you about units of measure and F Sharp. Now, I have said many times that I love the units of measure inside of F Sharp, possibly my favorite feature of the language, and honestly, the reason I decided to learn F Sharp. At the time, what was going on is I was doing a lot of financial analysis, optimization type of work, and units is an incredibly important part of it for allowing you to make sure that your math is correct. And I looked around, I had been following F Sharp for a while, and it's when I learned about this feature that I'm like, oh, okay, this is fantastic. This is going to be a game changer for me. And I started using it, and it was great. And since then, I've gone on to learn how to use units of measure in a lot of ways that it probably wasn't originally intended, but I have found incredibly useful, especially in high performance scenarios. So what I'm hoping to do today is kind of talk you through, how to use units of measure and some gotchas you should be aware of, and some of the things that I have found to be best practices for me using them. I am not saying that I'm sharing with you my experience. I'm not saying this is necessarily the best way, but having worked with them for a while, I have found these techniques to be really useful. So first of all, let's talk about defining our custom measure types. Now, F Sharp, the core library, does have standard, the international units built in. So there's some stuff just built into the language for you. But I find that a lot of the time I want to model my domain with units that are very specific to what I'm doing. So I need to be able to create my own custom units of measure. And so all you need to do is use the measure attribute on a type, and you can say something like this, where like, hey, we have now created a unit of measure, which is centimeter. And I could also define another measure type, and I could have one for second. And so these are just really, that's it. Now, technically, yes, you could also do this where the measure is on top of the type. I find that what I end up doing is I like to put all of my units of measure definitions in the same place. And so just for the sake of brevity, I like to do it this way. You do you. You can do it. Either way will work. And then how do we use them? Well, F-sharp units of measure, I believe, were originally intended only to be used with things like int, int64, float, float32. So let's say an example here is like I have 1 centimeter. And this part right here is how I am. And let me go ahead and zoom in. We got the space. So this annotation here on the float is how I'm saying like this is the units of that type. And so X is no longer just a float. It is a float with the units of centimeter. Fantastic. And we can define, I'm going to say X2 is equal to 3.2 seconds. And so, and rename that one to X1. There we go. We have one float. X1 is a float with the units of centimeter, and X2 is a float with the units of second. Okay, cool. Why do I care? Well, this is why you care. So now if you want to do something silly, like add those two things together, the compiler is going to say, no, this doesn't make sense. And like I said, I believe this was the original intention of the feature in F Sharp, is to verify algebra. When you're doing addition, subtraction, division, multiplication, do the units make sense? And as a former chemical engineer, tracking units is an incredibly important thing. Spend so much time doing unit cancellation and following units through a system. So here the compiler is helping us, because normally just two floats and you want to add them, like, yeah, the compiler says like, yeah, we can do that. But the F Sharp compiler is units aware, and it's checking and say like, no, the addition of two floats with different units of measure does not make sense. So it's going to stop you, which is fantastic. And what's also cool is that this is a true zero cost abstraction in terms of performance. There is no additional performance penalty for using units of measure in F Sharp. And the reason is because it's just a compiler check. The compiler is saying like, hey, do the units make sense? And at the end of the day, when it gets compiled into IL, all these units of measure disappear. They don't make it down into the compiled code. Now, probably the number one thing I get asked by people is, hey, can I use reflection on this? The answer is no, because it disappears. Units are only a thing inside of the F# compiler. After the F# compiler, no code is units aware. So you can't do reflection on a float and like, hey, what are the units of this? That is a feature for me because that's how you get the zero cost abstraction. Because this is going to have the exact same performance as if it was just floats. So for me, that's critical when using units of measure because I'm always thinking in terms of high performance scenarios. If something is adding additional correctness, but there's a performance penalty for it, like I know I'm working in .NET and you kind of have to make a decision about where in the spectrum you want to be because, I can't write C, which I know is like, oh, if you want to go as fast as possible. Like, I want to create fast code efficiently. And the units of measure allow me to do things that is the absolute fastest possible code, but with very low effort. And I think you'll see more of that as we go on. Okay, so we verified that addition is not going to work. Great. So let's try, hey, let y equal to x1 times x2. And this will work because multiplication of floats makes sense. And you're going to find that this value of y now has the units of centimeter seconds. So this is how you see the product of two units. And so you have float of centimeter seconds. Well, that's a bizarre unit. So you could also have division. And so when we divide, it's now float with units of centimeters per second. And so this would be something like speed. This is fantastic. So here we go. We see that algebra is working, units are flowing. Well, what happens if we want to define a unit that is like a composition of units of measure? So something like speed would be an example of that. So let's say for us, type speed is equal to centimeters per second. So now I have defined a type, which is speed, and its definition is the division of these two units of measure. And we could also do things like, I don't know all the units off the top of my head, so I'm just going to make something silly up. So we say like, hey, what happens if we want acceleration? And acceleration is speed per second. So it's like, yeah, I think that's correct. I don't work with acceleration very much, so pardon me. So yeah, we now have a unit of measure which is defined by a compound unit of measure, which is defined by these kind of fundamental units of measure. So this is great, and it could also be things where measure cannot spell when I'm recording. So we could also have something like, I'm just going to say something silly, like caret, I don't know. And caret is centimeters times second. And here I'm just showing that, like, yes, it is possible to define a unit of measure as the product of two other units of measure or as the division of another unit of measure. And what's cool is now I say like, hey, I have this speed here. And let's say I'm going to find S1 is equal to X1 divided by X2. And remember, this now has units of float centimeters per second. I'm going to say let S2 equal to, 2.1 speed. And so now let S3 equal to S1 plus S2. And what you'll see here is that the compiler, like, yes, we defined S2 as speed, but the compiler is smart enough to say like, well, the units of S1 are equivalent to the units of S2. So it's all good. Even though I have named this as its own unit of measure, the compiler is smart enough to know like, well, speed is defined as centimeters per second. S1 is centimeters per second. So like, yeah, this addition all checks out. So that's a great feature of it. And so I will often kind of build up my definition of units of measure. Like I'll have like the fundamental units of measure, like the base units of measure, and then I will start defining the more complex ones as I go on, which are the combinations of those fundamental types. Okay, so we've actually already covered this kind of addition and subtraction here. I also wanted to show, what else do I want to show? There's actually not a whole lot additional there. Addition and subtraction work as expected, and so is multiplication and division. I don't know why I had that separate things. But yeah, there you go. Multiplication, addition, stuff all checks out. And I could also say let S4 equal to S1 minus S2. So here I am doing the addition, compiler's doing the check, subtraction, compiler's doing the check. Stuff's making sense. Great. So there we go. That is defining them. Now, let's talk about another situation that you might run into. So everything I was showing there is typical stuff you would see in a physics book, right? But what happens if you want to use units of measure on these fundamental types, on your integers and your floats, and I think you can use them on most any numeric type in F# now. But let's say for your domain, the units only make sense on like a subset of floats or integer. So an example would be like, hey, I have some real world measures that can only be non-negative, right? So something like example of something I was working on yesterday. And so type pack weight. So pack weight is the weight of an item after it's been packaged to be shipped out. So it makes no sense. Let M1, I'm just going to use M1, say is equal to negative 10 pack weight. Like things don't have negative weights in our domain. And so we would ideally have the ability to constrain how these are created. And so what I end up doing is I end up adopting this kind of pattern where I say, hey, I have my module, which is units. I put everything in there. And so I'm going to move measure down into units. I'm going to move this on down. I'm going to move this definition of measure into here. And also what I end up doing is I end up putting that in a module, which is my domain. And this is going to make sense why I'm doing this here real quick. And I say like, hey, you know what? And I'm going to make it private. So now this unit of measure is hidden away. I cannot get to this unit of measure now, but I still want to work with it. So how do I use it? How do I create a float with the units of pack weight? Well, what I like to do is to adopt this pattern. So I have a module, which is pack weight. And this is going to hold when the air quotes constructors for floats with the unit of pack weight. And so I'm going to say let create, and I'm going to say, I'm going to have X, and this is a float. And I'm going to say, hey, first thing I'm going to do, if X is less than or equal to 0, then invalid arg, and go to just name of X, and cannot have non-positive pack weight as a message saying like, hey, now I'm going to check like, hey, is this actually in the domain I expect it to be in? And then what I will do is I'll say like, hey, X times 1.0 units pack weight. Where'd it go? Where'd it go? Where is it? There it is. And so now, if I want to create a float with the units at pack weight, what I need to do, and I want to get this whole thing on there, say like, hey, domain. Well, and I'm going to go ahead and open the domain. So I often open domain, and come down here and say like, hey, pack weight dot create, and I can say, hey, I'm going to try to do -10. Now, if I try to do this, it will throw an error here saying like, hey, it's not going to pass this validation. If I hover over M1, I can see like, yes, M1 is a float with the units of measure of units.packweight. By putting these units of measure in a private module and then having these create functions for them, I can force the user, often myself, to go through this validation to create them, so that if you want one, it's got to go through here. And so what this does is at the end of the day, when I'm writing my algorithmic code, I have some reasonable assurances about the domain of values that I'm going to be working with. Like, okay, well, I know if I have a pack weight, I know if I have a float with the units of pack weight on it, it is going to be a non-positive. It is going to be a positive number. It will be a positive number because I know it has to go through this check. So for me, this is incredibly valuable because it frees me to think about like my domain specifically and not having to think like super defensively. I could think just about like, in this case, like warehouse packing and conversions is what I'm working on here. And I know I only need to think about that domain. I don't need to think about like, okay, I also need to think about the fact that floats can be negative numbers and maybe someone put in some crazy thing. Like, no, like I have kind of sanitized the domain. So by the time I actually work on the domain logic, I'm free to just think about the business logic and what the business ends up needing. So I find this pattern of putting my units in a private module, defining create functions for them, and forcing everything to go through those is incredibly freeing. And I use this all over the place. Maybe there's a better pattern for doing this. I'd love to hear it. So what's cool is that units of measure can actually be used in your custom types. So let's say we want to define, and I'm gonna do some ridiculous things. Don't judge me. I just want to show you how to do the thing. So some of my examples may not make sense in the real world. So I'm gonna define this type animal, and it is going to take as a type parameter a measure. I like to use measure instead of T. I like to use measure in my case, and it is going to be an F# record, and it's going to have a single field of float. Now, why would I want to do something silly like this? Sometimes you want to add additional validation to your types and which types can work with each other, but you don't want to have to define a whole bunch of types. And so you can use units of measure as a way to differentiate. And so like, hey, I'm going to have another measure here. And I know this is ridiculous. So I'm going to have a type measure of cow. I'm going to have a measure type chicken. Right? And so now I can say like, hey, I can define an animal. Let's say, hey, C1 in this case is going to be a size equal to 1.0. And right now, the compiler doesn't have enough information to figure out like, hey, what is the unit of measure on this? So there's kind of a few different ways you can go about this. You can put in a type annotation here and say like, hey, it's chicken here. That is not, I mean, yes, I'm showing that you can do it. Not necessarily my recommendation. So now if you wanted a cow, you would say animal cow equals size equal to 1.0. Yes, you can technically do this. What I prefer to do is to do something where I'm using unit information on the constructor for the type. And so again, I'm going to say, hey, static member, how how exactly do I want to do this? Oh, I'll just do it this way. So module animal let create, and I'm going to have a float, and it's going to have a measure on it. Oh, and I need to talk about something real quick. So right now, this is going to throw an error. And what's weird is if I get rid of this, it won't complain. This is a compiler bug. I've already filed it. There is a way to work around it. You kind of have two different things you could do. You could put this type in a separate module. Oh, animals. You could put it in a separate module, and that's enough for the compiler to say, like, oh, okay, like there's now no longer a name conflict going on here. You could do that. I find that a little annoying. I mean, it's a design decision on your part how you do it. The way you get around this is you use this annotation here, which is compiler representation flags module suffix. And so, no, why? This should, oh yeah, this has to be on the module. So you put this on the module, and what it does is it tells the compiler, like, hey, when you're generating the types behind the scenes that are getting compiled into the IL, you're going to need to add a module suffix to this. Now, if you I'm just gonna say it's a bug. But I'm hoping to work on it. I'm getting some help from some people. In the meantime, like I said, you can use this kind of compiler flag, or you can put this type definition in its own domain. So there you go. That way you don't have any conflicts. So what I'm now going to do is I'm going to finish this create function. And what I'm going to do is going to say, like, I can do this. We're going to say, like, hey, this is going to return an animal, and it's going to have the units of measure that is on this float. And so I can now say size equal to float x. And why am I having to do this float thing here? It's to strip the units off of the float. And don't worry, there's not a performance penalty for doing this, because by the time it goes to the compiler, it says, like, oh, you're calling the float function on a float to convert it to a float. Well, it's already a float. And so it just disappears. You don't have to worry about it. So this is one way of doing it. And so down here now, and I'm gonna have to zoom out a little just so we can get all this on the same screen. I can do this, which is definitely my preferred approach for doing it. It's like, hey, animal.create, and I have 1.0, and I'm gonna give this an annotation of cow. Well, nope, this one's the chicken, I think. Yeah, this is the chicken. And I'm gonna get rid of this. I say, like, yep, this is an animal.create and 2.0 cow. I know these are silly examples. I'm just showing you different approaches that I've used. So this is useful. And so again, we're able to use the units on the input types to control what are the types of things being created on the other side. Great. What happens when I want to define, like, addition of types? And again, in this domain, this is nonsensical, but I just want to show you how to, like, do manipulations with units of measure so that you can kind of define your own algebra. So let's say I wanted, for some bizarre reason, to say let C3 equal to C1 plus C2. Like, I wanted to be able to add animals together. Well, first of all, it's going to say, like, there's no definition for addition on this type, so you need to add that. Okay, so let's go ahead and add addition to animal stack member plus I'm gonna have a, and this is gonna be an animal with type measure, and this is gonna be B and animal. Come on, measure, and I am going to say, hey, you know what this is going to return? This is going to return an animal with type measure. And here, I'm going to say size equal to a.size plus b.size. I know this doesn't make any like physical sense. I'm just showing you how to do it. So now I've defined addition. And so it's still going to say like, yeah, okay, well, this doesn't work because these types aren't lining up the way we want them to. And so like, let's go ahead and change this to chicken. And now the compiler is going to say like, yes, your units, your types are now lining up. And part of it is because we've added this units of measure annotation to types, and that unit of measure is all lining up. So let's say I wanted to define and create a new thing here. This is going to be an animal, create, and 1.0, and this one's going to be a cow. And let's say I wanted C5 to be equal to the product of C1 times C2. And again, I need to define like what is multiplication for this type. So again, I'm going to add a static member, and I'm going to say like, you know what? I'm going to define multiplication. Now here's something you should know if you ever want to define multiplication on a type in F#. Paren star is the beginning of a long comment. So you need to put a space in between. So that's something that kind of annoyed me, but that's how you do it. So now I'm going to have animal, and I'm going to have what I'm going to say left measure. And I'm going to have B, which is animal R measure. And this is going to return an animal of L measure times R measure. And here we go. Size equal to A size times B dot size. Now, here's the thing. I would think that this should work just fine. It doesn't seem to. And so what I end up having to do, yeah, this construct causes code to be less generic, blah, blah. Okay, so how do we get around this? Well, this is what I end up doing. So I'm going to take that and go down here and say home let result equal to and return result. This works. So my intuition is that the other thing should work, but again, we're kind of in some, probably near the edges of the compiler at this point. And so now I have defined that the multiplication of animal is going to give me an animal with units of L measure, R measure. You can think of it as there being an asterisk here to symbolize multiplication. Compiler doesn't show it. It's essentially what it is. It's the product of those units. And so now we can see that the C5, well, in this case, it's chicken squared. Oh, I wanted to multiply by 4. Cool. So C5 is now an animal with the units of chicken cow. And let's say we also want to do something silly like be able to divide animals. So C6 is equal to C1 divided by C4, right? Again, we don't have division defined for this domain. So let's go ahead and do that. So I'm just going to copy this just to kind of streamline some things. I'm changing this to a division. And now I need to change these units to be like, hey, this is L measure divided by R measure units. And so C6 now has the units of animal of chicken divided by cow. So good times. Okay, yeah, I've already defined that, leaving notes for myself, and then I end up just doing it. So this can be really useful when you have more complex types that are meant to represent your domain and you want to have units of measure on them as an additional kind of compiler safety, and you want to define like what addition, subtraction, and these other units, you want that to flow through. This is how you do it. And I've used this a lot in other libraries. So I find it incredibly useful for being a zero-cost abstraction. There's one last thing I wanted to share with you as kind of like a hint to make your life easier sometimes. So let's say, hint. Let's say you're dealing with a situation where hey, I have, what have I not used yet? I haven't used Q. Q1 is equal to 1.0, and I had cow up above, and I had Q2 is equal to 2.1 cow chicken, and let's say Q3, I wanted that to be Q1 plus Q2. Now, the compiler is saying like, hey, you can't do this. And what often you will need to do is define some conversions. And so it can be really convenient to have some converting constants for your domain. But let's say you don't have that and you're just like, you know what, I just need to convert this. I just for some reason. There's this incredibly helpful things where you say like, yeah, compiler, I just want you to figure it out. And what this is doing is it's saying like, okay, well, you have Q2. I see that you're wanting to add it with, you have this, okay, so Q2 is this float chicken. I see that you have this float cow. You want to add them together. Therefore, the units of this float that you're multiplying must be the units necessary to convert this to what it is that you need it to do. Now, again, this is a zero cost abstraction because the compiler, and I'm not sure if it's the F# compiler or the CLR, it sees multiplication of by 1. And it's like, well, that's nothing. So it gets rid of this. It disappears. And so you don't actually pay any penalty for doing this multiplication because by the time it gets to the CPU, it's not there. So this can be a really quick and easy shorthand to just like convert something to whatever it is that you need to do just to get the job done. But again, a lot of times you can also in your domain define, let's go all the way back up here. Oh, no. We're here. So we have this like pack weight. You can also have something, a module, which you do expose, which is conversions. And this is a place where you could put convenient conversions for your stuff. So we can have, hey, let, I'm not even going to let, pack weight to kilos. Okay, that's actually a terrible one, but okay, I'm not going to do it. But let's say like, this is what I end up doing as my convention is like, hey, I'm going to put the conversions if I want, like, so from kilos to pounds, if you're doing something like that, this is where I would put that. So yeah, units of measure is a fantastic feature for being able to work with raw primitives. And so therefore getting the speed and performance of raw primitives, but getting additional domain correctness. So I hope you found this helpful. I use this all the time. If you have additional questions, please feel to reach out to me. I love answering them and helping people. And if you have any other ideas, I'd love to hear them. If you're like, oh, Matthew, there's a way better way to do that. Oh, I absolutely want to hear that because, yeah, for me, this is just a ton of fun. I really get a lot of joy out of it. I'm really glad I get to share it with you. So thank you for spending some time with me today. I hope you do well. And yeah, have a great one. Bye.